there, my name is Rebecca Regan, and I am at Olympic College with Math 147. And I'm going to be talking about my math final project, which I decided was fuzzy logic. Let me just get to the top here and present. So I originally was drawn to fuzzy logic. I actually had not heard about it at all, but I liked the name, so I looked it up, and I actually thought it was really interesting because I didn't realize how often we use it, and that's why I decided to choose this topic. So let's just get into what is fuzzy logic. So fuzzy logic is an approach to variable processing that allows for multiple values to be processed through the same variable. Fuzzy logic attempts to solve problems with an open and precise spectrum of data that makes it possible to obtain an array of accurate conclusions. So one thing that helped me understand fuzzy logic was comparing it to the logic that we know, the mathematical true or false. So if you think of the baseline logic as 0 or 1, and then you think of fuzzy logic as 0 to 1, you can see that the fuzzy logic kind of gives more details within that gray area. So for example, fuzzy logic could be 0.2 or 0.225 or 0.1, whatever. I mean, anything in between 0 or 1 could be that differentiating fuzzy logic, whereas it's not just 0 or 1. Another example would be general logic would consist of true or false. This would consider no other possibility. An example is if it's true, then it's not false, and if it's false, then it's not true. Whereas fuzzy logic would look at it from more adjustable terms, reasoning kind of like a human would, which is what it was based on. Fuzzy logic could say, if it's true, then this possibility, or this possibility, or this possibility. Or if it's false, then this, or this. It doesn't necessarily mean if it's true, then it's not false at all. There's not that, yes or no factor, which is really cool. And some other examples more like verbally would be, so Boolean logic, really quick, is basically general logic of what we were talking about. It's just that basic yes or no. So for that, it would be if it's hot water, yes, it's hot water, or no, it's hot water. Or for fuzzy logic, if you said, is it hot water, you would say, it's very much hot water, it's a little bit hot water, it's very less hot water. Those things all could kind of go in if it's cool, lukewarm, freezing, or boiling water. Those are all fuzzy logic because they consider other examples. So some fuzzy logic that we use in real life. So here are some machines that we use often. These helped me understand more why is this relative and why do we use it. These things we obviously use all the time, and there was a ton more of examples, but these ones I could understand in a clear way because I use them. So the first one is a vacuum. The vacuum can suck up more or less pressure depending on where it's at, how much it needs to suck up, or what texture it's on, and all of those things are very relative to its circumstance. Whereas facial recognition technology to unlock your iPhone, that's really cool because one day you might, dye your hair pink, or you might be talking to someone while you unlock it, or your face is a little bit altered. It's still that relative face and the bone structure, but there's different things affecting it. And I've seen many times where siblings have been able to unlock someone else's iPhone because they look alike, or possibly twins, and that's because relatively they have the same face, but it's not exact. The thermostat we're going to talk about in this one. But before that, for fuzzy logic programming, another thing is driving. So if brake temperature is warm and speed is not very fast, then brake pressure is slightly decreased. That helped me understand that when you're driving, we are using fuzzy logic all the time because when you're driving, you're not hitting your brake or hitting the gas really fast. You're relatively kind of interpreting the circumstances and what you need to do, and it's not black and white. And then going back to the thermostat, this original example was the one that kind of helped me understand how it programs into technology. So if the temperature is very cold, then the fan is stopped. If the temperature is cold, then the fan is slow. If the temperature is warm, then fan speed is moderate, and if the temperature is hot, then fan speed is at high. So those things are always adjusting to that first factor, the if-then property. And then the history of fuzzy logic. So this man is named Lofty A. Zeta. He was an engineering professor at UC Berkeley, and obviously this study and finding is relatively new because he published this theory in 1965, and His idea was based off of his frustration with computers, and they were unable to comprehend more complex ideas beyond just true or false. And he just wanted to fix it to where it thought more and was able to like comprehend more ideas. And this idea of fuzzy things and fuzzy logic was quickly and widely accepted in Asia, but not at all in the US or Europe. It actually took them a while to pick it up, and in a lot of the websites when I was researching, many were skeptical that it was due to its unique name, fuzzy things. I honestly could see this because it's so different than the regular mathematical terminology that, like, you would think that you shouldn't take it seriously, but it wasn't because of his ideas, it was the name that kind of turned people off. But because Japan and China grabbed onto it more quickly, they are more advanced in fuzzy logic technology today. Currently, right now, they have 10,000 scientists specifically studying fuzzy logic and its possibilities of like growth, which is really interesting because that kind of tells you that we're just at the beginning of using it. And that's about it. Here are my sources, and I have a lot more sources that I got my information from in my essay. This is photo sources though. So, anyways, thank you so much for watching, and